Hello, welcome all to this talk on improving QGIS plugin developer experience. Little background about me. My name is Antero Komi and I'm a software developer at Antero Finland. It's a governmental entity responsible for external topographic database. And about our QGIS plugin development, we do our topographic data production system is currently in development, and we have a few other similar systems in use already, which are basically plain QGIS with the features provided by custom QGIS plugins. And the issues we face with our developer experience were firstly the dependencies. We use Git submodules, which I believe many of you use. It's a bit difficult to organize together with dependencies that are provided from Git installs or elsewhere. And also with that, if you control the repository where you have the submodule, you also have to use the relative imports because the submodule will be in the namespace of your package. And also, there's the debugger setup. When you want to debug QGIS plugin, we also have often duplicated the code in our plugin package before the class factory method, so that we set up the debugger there. And also for the development environment, so that you get the QGIS running with your plugin and ready for development. For us, it was a collection of shell scripts to make the QGIS launch with the plugin path. Or maybe there was one implementation of where the plugin was actually symlinked to the profile directory, so that also was a bit complex for our plugins. And also with the dependencies that are not Git submodules, if you want to use, for example, any library from Python package index, you must have the dependency available at runtime. So in the environments that you do not control, it's a bit difficult. You have to prompt the user or make the user install it, like mention it in the README. And for distribution, in the environments that we do control, it's another step to make it in the base image or install it in a separate step on the deployment pipeline. With all those approaches, because you can have only a single version of a library in a single QGIS session, you can't really make sure that it's the version that you want. Like if the user has a library installed in the QGIS environment and some other plugin imports that before your plugin does, it will not be that version that you, for example, bundled in your own plugin, and maybe added that to the path via some code in your plugin. So to solve these issues, we created a library called QGIS Plugin DevTools, which is essentially a command line tool to improve the developer experience and make the dependency management a lot easier. It's available in our GitHub and also installable from Python package index. And what it is, it's essentially 3 commands. There's a start command, which has the development mode. Then there's the build command, which is a plugin creation, and a publish command that is the when you push it to the QGIS plugin repository. So it's has all the 3 main features covered. And what it does, the start command, it's a command to launch the QGIS with the current repository for your environment ready for development. So the plugin code is sourced from the environment. Like you have to have the plugin installed or available to import from the environment you run this tool from. And the dependencies are also available from the current environment. Like for example, we use virtual for our development. So the dependencies can be installed with that, and it's available in the QGIS after it's launched. And also the debugger server code is moved to this library, so we don't have to duplicate that in each one of our plugins. So this handles that, and we don't have any like non-runtime essential code in our plugin code. And also it works with editable installs. If you have a library that you are developing together with your QGIS plugin, it also creates some hooks to the QGIS reload plugin commands to also reload the dependency library as well. And what the push command does, it basically creates your plugin zip file. It does this by bundling the runtime dependencies into the plugin zip file. And it's also compatible with the other Python package tooling, like for example we use setup tools for our the normal Python package, and the version can be sourced from the installed distribution method. And if you compare this to the Python package tooling, you might compare it to build, which is the Python package operating like standard minimal build command. And the next command is the buffers command, which is like very simple, comparable to Twine, which just pushes your package to QGIS plugin repository. And we created this in addition to the library we used previously, because we had issues in our environment with proxies, because the XML RPC library it's not that well supported. So this one uses requests via JSON RPC, so that works with the standard proxy environment variables. And how has this improved our developer experience? We get the dependencies from the environment. So in a normal workflow, we can just take any dependency that's a well-formed Python package and use that with pip install and do the imports from there. And it works in the development mode. And also we can use absolute imports so that we always know like what the package is, because if you have relative imports and you have like very nested namespace, the submodule will be found in like we have 6 dots. And it's not that obvious like where the module is imported from. And also the debugger is set up in the tool, and the developer environment is set up like you start the package with the command and you get the QGIS. And the improvements in our dependencies, we can use any well-formed Python package so that the library can be installed in the virtual env and we have it available. So this works for us mostly for sharing common code, for example UI components, etc. We have one common library we use called QGIS plugin tools, which has like login setup, some UI components, some of the helpful code that we often use in all of our plugins. And also this should work with most other Python libraries that don't have any complex imports or binaries. For example, we took a dependency on a library called Qt-utils, which had some helpful code for managing our threading issues. It's often a problem if you use the GUI thread from another thread in QGIS, so it often crashes. So with this Qt-utils library, we found a decorator that we can just use to execute some code always in the main thread. In that, there was actually quite complex logic to handle the possibility of two different Qt implementations, like the high side or the Qt. So we also could replace that. So how does the dependency management work? When you add this tool or use this tool, you declare your current Python package name of your plugin, and then you declare the runtime packages that you have in the environment or in your code. And in your code, you can just use the import from the package, as is, for example, here. If you use some dependency, import something from that, and just use those as is. And with this configuration and this code, after the boot step, the code becomes like shown in the picture, where actually the dependency is moved to a namespace below your plugin, and all the imports in the code are actually replaced to match with the new namespace. It works due to this import replacement logic. This is the reason why it works like for the most simple or well-formed Python packages where there is no complex import logic or any dynamic imports that we can do the replacing at the full step. So, for our improvements also in our sharing our code, with this style of using dependency libraries, we can also often share both the library as a normal Python package, and we can share the plugin as like a reference implementation for the library. For example, our quality checker, it's mostly used as a library. It's basically a GUI component that displays a JSON geometry metadata in a drop widget. So we use it as a library, but for development, there's a very simple wrapper where you can basically add a JSON file, and it just calls the same API as we do in our own code. And with this, you can use the library API instead of accessing, for example, a plugin instance from the utils package in QGIS. And also with this structure, there can be two versions essentially of the same code. For example, our segment reset plugin, also in our GitHub, we use it as a library for another software integration, where we basically provide the same feature in another, like a remote editing application, and then we have it also available as a plugin to the user. So in our own code, we use this library. We can have a specific version, and the user can install whatever version of the plugin. So those will not conflict at runtime, so we don't have to manage the, like for example, if you have a break and change, user can install that, and we don't have to yet change our own code. So how do you start using this tool? You have to set up your repository as an installable Python package. It should work also if you have a root package in your repository and use the Python m command, which magically adds that working directory to the path, but it's often easier to have it as a Python package in the environment. And to install and configure this tool, you have to have the package name, as shown previously, and if you have any dependencies, declare those as well. And then for development, you just set up your .env file, which has a path to your QGIS binary. So with that configuration, it just basically launches the binary path we provided with a bootstrapping code that will actually do all the debugger setup, environment setup, and install your plugin available. And if you have dependencies as submodules currently, you could allow use of those as Python packages. You can do that even without changing the actual submodule code in that step. We actually did the change to the QGIS plugin tools repository, which was a submodule before this implementation. And then you install your runtime dependencies, in the same environment, and you switch your submodule imports to the plain module name imports from the environment. That's all for the tool. You can find it in our GitHub. There's also the other plugins mentioned in my talk, and you can contact us at this